All right, so here we go, guys. Welcome, welcome. All right, from the 2011 exam, all these questions are from College Board. They're all official questions. They're not mine. And it says from the 2011 exam, this is a question that just was for AB. Between 0 and 6, a particle is moving along the x-axis, so it's just one-dimensional motion. The particle's position, x of t, is not explicitly given. The velocity of the particle is given by, and then they give me my velocity equation. The acceleration of the particle is given by, and then they give you the acceleration. They didn't have to. They could have made us take a derivative of that, but they decided to give it to us there. And then this is my initial position. Initial position. And I don't like to use the word initial because sometimes like they'll say x of 3 equals 5, and that's like quote unquote initial position, and the time's not 0. But usually if it's time 0, you just call it initial in physics. All right, letter A. Is the speed of the particle increasing or decreasing at time t equals 5.5? Give a reason for your answer. Particle increases or decreases in speed if the velocity and acceleration have the same sign. Well, okay, I should be specific. If velocity and acceleration have the same sign, the speed is increasing. If velocity and acceleration have opposite signs, the speed is decreasing. That's all it is. They already give you the velocity equation. Type this into y1. They give you the acceleration equation. Type this into y2. And you're literally good. I would not write y1 and y2 on the exam itself. So here we go. I'm going to take my calculator out. Y equals y1. Let me clear this. 712. And y1, 2 sine. What do I have on this side? The sine? E to the t over. Okay, e to the what? Over 4, right? Sorry. Yeah, your calculator should be in there, and it should already be fully charged too, by the way. That's it for that. Oh, plus 1. Plus 1. Okay, and then for y2, what is it? 1/2. So let me put the fraction here. 1/2. And then it was it e to the t over 4. And then what else? Cosine e to the same thing, right? T over 4. T over 4. All right, there it is. Okay, here we go, guys. I got it in there, so I can quit. And by the way, show them that you know what you're doing. Well, actually, they already give you the acceleration formula, so I was going to say take a derivative of velocity, but don't. Just go v, and then put this time in there. 5.5 equals, and then give me that number. So I'm going to go alpha trace. I have velocity in y1. Just don't confuse them. Which one's in which one? 5.5. I'm going to push enter, and here's that number, negative 0.4533 or 4534. Negative 0.4533. I like truncating. A to the 5, A of 5.5 equals, and I do the same thing again, guys. Alpha trace y2, that's where my acceleration's at 5.5. And I push enter, and a negative 1.3585. Negative 1.3585. Okay, velocity and acceleration have the same sign. What's happening to the speed? Yep. And it says give a reason for your answer, so I'm going to say speed, and I just use their language, guys. Just use the stem of their question. Speed of the particle is increasing at t equals 5.5 since v of 5.5 and a of 5.5 have the same sign. Done. Full credit. You could have also said since v of 5.5 is negative 0.533 and a of 5.5 is negative 1.3585. That's fine. But there it is, and we're good. What do you guys think? Not bad, right? All right, letter B. Find the average velocity. Ooh, I love it. I love it. Underline average velocity of a particle for a time period between 0 and 6. How do I find average of anything? Yeah. 1 over 6 minus 0, integral from 0 to 6. And what do I put on the inside of that? Do I put v prime? Do I put v? Do I put a? V. Chop, why? Remember, okay, remember, average of f is 1 over b minus a integral a to b of f of x dx. But Chav, isn't the integral of velocity displacement? Yes. And then I'm dividing by time. So this is displacement, and I'm dividing by time. And look, and I still am going to get meters over seconds or whatever. Oh, they don't have units on this. But distance divided by time, which is meter per second. So there it is. This is average velocity. So does that make sense, guys? If they would have told me average acceleration, I would have done integral for the acceleration, or 1 over b minus a, integral of acceleration. But they wanted average velocity, so there it is. If you want average of anything, there it is. Sometimes they say average rate of change. Relax, rate of change, y2 minus y1 over x2 minus x1. But this is average velocity, so you take the velocity, you integrate it, and you divide by the time. How do we feel? All right, this is called the setup. They already give you the equation of v of t. I would not write in the expression. You can if you want. So there it is. I'm just going to take my calculator. I have that in y1. So I'm going to go alpha trace y equals, if you want it to look exactly like that, right? 1 over 6 minus 0, or just 1 over 6. And then math 9 from 0 to 6 of alpha trace y1. That's where I have my velocity. And I push X, and I push Enter, and there it is, 1.94938. If there was units, you would put units, but there's not any units on this. I forgot it. 1.94938. 94938. And that's it. We feeling okay, guys? Okay. Find the total distance traveled by the particle between 0 and 6. How do I find total distance? Absolute value. Perfect. See, you guys have got it. Total distance equals integral 0 to 6, absolute value. Absolute value of what? Of velocity, right? If you don't put the absolute value, it's displacement. So there it is, absolute value of velocity. I'm going to take my calculator. I'm going to go math 9, 0 to 6. How do I find the absolute value button? Math and number. It's the very first one. ABS, and then just type it in. Alpha trace y1, and then put an X on this guy. Oh, not there. Delete, boom, X, enter. And there it is. 12.5732 is what I got. 12.5732. And if there are units, you would put units, but this one doesn't have any units. All right, letter D, it says between 0 and 6, the particle changes direction exactly once. Find the position of the particle at that time. Okay, well, I already have y1 in my calculator. Turn off y2. So here I am. I'm just turning it off. And I'm going to click on window. I'm only looking between 0 and 6. And if you want to hover between the x-axis, that's what I would do. So I'm going to hover between the x-axis. I'm going to go between -2 and 2. And I'm going to push graph. And there it is. That's the only time that I change directions. So I'm going to find that value. So what do I write? Here's what you're going to write. You're going to write v of t equals 0. This is called the setup. And then right below, you're going to tell me t equals, and you're going to give me that number. So I'm going to come up here. I'm going to go second calculate number 2, 0. And then it's telling me search between what? 1, 2, 3, 4, 5. So I'm going to push the number 5, enter. And then I'm going to push the number 6, enter. Right bound, 6, enter. And then it says, when I say guess, no, I don't want to guess. Boom. There it is. Okay. Or you can use a little scroller thing, left, right. Pick it up. I don't know. It's right there. It's there's like, I think it's the first 4 sheets. All right. So there it is. And 5.1955223. So I'm going to put 5.19. Did I say 223? 5.1955223. 55223. And I'm going to tell it that I'm going to store this to A, so I don't use all those digits. I'm going to go store, and I just put capital A. And then I can do this. It says, find the particle change direction exactly once. Okay, so there's where it changes directions. And then find the position of the particle at that time. Okay, position. Here it is. I'm going to go x of A, so it knows that it's talking about this value, equals my initial position, which is this guy right here, 2. That's x of 0, plus my displacement, integral from 0 to A of velocity. And that's going to tell me my new position. So my position at that time equals, and I'm going to write what that position is. Hey, Sabetta, grab the first 4 sheets on that table. I didn't staple them, so I'm sorry, miss. So here we go. I'm going to go second quit. 2 plus math 9, 0 to, was it at 6? Oh, H. I never stored it to A, huh? Look at that. So I'm going to clear this first because I never stored it. X, let's see if it's still there. Was it 5.1955? Okay, store to alpha A. And then now we're good. So 2 plus math 9, 0 to A of Y1. Alpha trace Y1. And I push enter and I 14.13477. 14.13477. And there it is, guys. I haven't looked at this rubric in particular. I was looking at other rubrics last night, but I don't remember recalling this one here. All right, so let's College Board 2011, scoring guidelines 2011. And here we go. Let's see how we did. So negative 0.45337, negative 1.3581. Conclusion with reason. The speed is increasing at t equals 5.5 because velocity and acceleration are the same sign. I think we wrote the exact thing. Hey, Meta, pick up 4 sheets on that table there. It's on this, if you want, of course. Average velocity, look, ours look exactly like theirs. If you want, you could have put the velocity integral and then divided by 6, the whole thing. But I like this look. Distance, it's going to look the same for everyone. Did we get that value, 12.573? There it is. And then V of t equals 0 at t equals, yeah, look, why did they use the letter B? I don't know. I just go down the alphabet and, they just choose whatever random letters. I guess because the upper limit. Okay, anyways, I was going to talk about a textbook, but that's fine. V of t changes sign from positive to negative at time t equals B. It'd be nice if you said that. I didn't say that. Why didn't I say that? Because it told me here the particle changes direction exactly once. Find the position of the particle at that time. So I found where the velocity was 0 because that's the only time I changed directions. Now that I'm thinking about it, I probably should have said that. I think we're good. I think we still got it. And then check it out. Ours looks exactly like that. 14.134, 14.135. We got all 3 points. So there it is. Next question. This one's contextual, but it's also differential equations. Let's talk about the question. As a pot of tea cools, the temperature of the tea is modeled by differential function h between 0 and 10, where time t is measured in minutes and temperature h of t is measured in degrees Celsius. Okay, so far we're good. Values of h of t, so the values of time t are shown in the table above. All right, before you even start, it's contextual. Do we know what's happening? You have a liquid, a tea, and it tells you that all they did is, they heat up, they like their heat hot. So it's hot, it's in degrees Celsius, and they just poured it, and it's somewhere, and it's cooling off because it's no longer being applied heat. That makes sense? All right, let's see what the first question says. Use the data in the table to approximate the rate at which the temperature of the tea is changing at t equals 3.5. Show the computations that lead to your answer. Okay. Chop, what are they asking? Approximate the rate at which the temperature of T is changing. So it's like saying a derivative, but notice I don't have an equation, H, but I have a table. 3.5 is right smack in the middle between what 2 values? 2 and 5. So what you're going to do, you're going to go H of 5 minus H of 2 divided by 5 minus 2. You probably don't have to show that step right there. You can probably go right into it, but it'd be nice if you showed that. And you're going to go 52 minus 60 divided by 5 minus 2 equals, and I'm going to take my calculator. If you wanted to just divide by 3 there, that's fine, no big deal. So here we go. I'll take my calculator. I'm going to go, I guess you don't need it, but I'm gonna do it anyways. What was it? 52 minus 60, so negative 8. I'm just going to write 52 minus 60 so you guys can see it. Over 5 minus 2. And there it is, negative 8/3. If you don't want a fraction, you can write it as a decimal by just doing math number 2. Whichever one you think is easiest. I'm going to write it as a decimal, negative 2. No, it doesn't matter. Negative 8/3. Negative 8/3. The difference on the top is 8. The difference on the bottom is 3. And do they want units? Show the competition. Use the data on the printer. You should put units if possible, but this is degrees Celsius per minute. You could also have written, I'll write both of them, negative 2.666 or negative 2.667 degrees Celsius per minute. And you can always write more digits, right? And that's it. There it is. That's letter A. This one wants units. Let's see what it says. Using correct units, explain the meaning of 1/10 integrals of 0 to 10 of h of t dt in the context of this problem. Use a trapezoidal sum with 4 subintervals indicated by the table to estimate 1/10 integral 0 to 10 of h of t dt. Okay, before we even get started, what does that mean? Where have you seen this before? We just did it a little while ago. That's average. That's average, guys. We just did a little while ago. This is average. So what do you think this is average of? Yeah, it's the average temperature in degrees Celsius of the T between T equals 0 and T equals 10. So that's what the first thing I would write, because I like to answer questions in order. So that's the first question they ask, and correctly is explain the meaning of that in context of this problem. So I'm going to say 1/10 integral 0 to 10 h of t dt means the average temperature of the T between T equals 0 and T equals 10. Is this in minutes? Minutes. Period. You could have also said within the 10-minute interval, whoever's grading your exam, I mean, that's correct. It's within that 10-minute interval from 0 to T equals 10. So there it is. I answered the first question. Now it says, use the trapezoidal sum with 4 subintervals indicated in the table to get this. Let's see, are my heights all the same? Nope, they're not. So don't even bother. I guess if you memorize the formula for how to figure out area of a trapezoid, if you have equal heights, you could use it. But don't just do it. Look, here are my 4. 1, 2, 3, 4. The height of your trapezoid is your delta x. The bases are these. Does that make sense? So here it is. I'm going to go 1/10 integral 0 to 10 of h of t dt equals 1/10. That 1/10 is this one. Bracket. And now I'm going to write my trapezoid. So base 1 plus base 2 times height divided by 2. So here we go. I'm going to go parenthesis. Base 1, so the 66, plus base 2, the 60, close times height. The height is 2 divided by 2. There's my first trapezoid. Man, I'm going to see if I can fit them all in here. Plus, again, I'm going to continue. The 60 is part of it. Parenthesis, 60 plus 52, close times. The difference between 5 and 2 is 3 divided by 2, plus, I'm going to keep going, 52 plus 44. 52 plus 44, close times. The difference between 9 and 5 is 4 divided by 2. Dang, I wanted to put them all in one line there. Plus, and then 44 plus 43 times 1. Oh, man. Times 1 divided by 2. And then close the bracket. All right, there it is. I'm going to go 1/10. I'm going to put a bracket. I'm going to put what that number is. Did you guys already figure it out? Or? All right, I'll do it here. Alpha fraction. Hook me up with the numbers, Luis. What I have? 66 plus what? 60 times what? 2 divided by 2. I guess the 2's cancel out there, so I didn't have to do that, but that's fine. Plus, what's the other fraction? 6 plus 56 times what? Divided by 2 again?
Is it 56 or 52?
I heard 56, but 52 times 3. And since I didn't put parentheses, I guess I could have just put them on the outside. Second, insert parenthesis times 3. There it is, divided by 2. All right, what's the next one? 52. I mean, I know the first one there because I can see it from there. Plus 44, and then times what? Is it 2? Let me check. Times 4. Times 4 divided by 2. Do you know where I'm getting the heights from? Be honest. Okay. And then the last one was what? 44 plus what?
43.
43 times 1, right? You don't have to put the 1 there, but I did. And then enter. Let me turn that into a decimal. 2. You can also turn things into a decimal, 529.5. But here's a hack in case you want to see it. This 1059 over 2, if you don't want to push the math button to go to decimal, you can go times 1 and put a dot. See? And that forces it to be a decimal. That's a hack. It's not a big deal there. 529.5, that's not the temperature. You still got to divide it, but I wanted that for this. 529.5. And then divide that by 10. So 52. I need more digits. Oh, I guess it'll be 950, so it doesn't matter. Divided by 10. Yeah, 52.95. Trav, you told me to always put 3 digits after the decimal. You can put the 0 there if you want, but you don't need it. And I need units, so this is going to be degrees Celsius. How do you feel? Trav, do the units make sense? That's not, I don't see him canceling. It makes sense, guys. H of t is in degrees Celsius. dt, that's just a change in temperature, area under the curve. Degrees Celsius, I think it was a minute per minute. So degrees Celsius minute, and then I'm dividing by 10, which is minutes. So the minutes cancel out and you just get degrees Celsius. In case you're wondering. Maybe you weren't, but just in case. And then the height, you get it from your delta x. See, the height of the first trapezoid, that's 2. The height of this trapezoid, the difference between 5 and 2, that's 3. The difference between 9 and 5, that's 4. And the difference between 9 and 10, that's 1. That's your quote-unquote heights of your trapezoid. Does that make sense, guys? Do we have any questions on this? Okay. Well, let me know. I'm pretty sure they're going to give you a table, LRAM, MRAM, RRAM, or trapezoid, and we'll see what's up. All right, next one. Evaluate integral 0 to, man, so they're really hitting us with FTC on this one. 0 to 10 of h prime of t dt using correct units. Explain the meaning of the expression in the context of this problem. All right, let's first evaluate this. What is the antiderivative of h prime? What is it? H, just h, yeah, h of t. I'm evaluating h of t between 0 and 10. You don't have to show that. You could just go right into the answer. So I'm going to go h of 10 minus h of 0. All right, what's h of 10? H of 10 is 43. So I'm going to write 43 minus, what's h of 0? 66. All right, let's see, what is that? 43, 53, 63, negative 23 degrees Celsius. What does that mean in the context of this problem? Yeah, the change in temperature. You can either say the change in temperature, I would write it, because remember, it's in context. So I would write it as the T has cooled by 23 degrees between T equals 0 and T equals 10. Does that make sense? So I would write a sentence. It says, explain the meaning of the expression in context of this problem. I would go, the T has cooled, and we'll read the rubric in a little bit, what they wrote. The T has cooled by 23 degrees Celsius from T equals 0 to T equals 10. Or maybe you want to write it, the T has cooled by 23 degrees Celsius in the 10 minutes, if you think that's better. I haven't read the rubric, guys. I don't know. We'll see in a little bit. How do we feel? All right, we got another one. What do you think, Arnold? Is this good stuff? Are you liking it? At time T equals 0. All right, no, ask me, guys. Ask me, Muñiz. At time T equals 0, biscuits with temperature 100 degrees Celsius. Ooh, that's hot, guys. Were removed from an oven. Okay. The temperature of the biscuits at time T is modeled by a differentiable function b, for which it is known that b prime of t equals that. Okay. Using the given models at time t, I typed this out myself. That should have been equals. At time t equals 10, how much cooler are the biscuits than the tea? Okay. We'll figure out what the temperature is of the biscuits. Let me make sure. Okay, here we go. So I'm going to write temp of biscuits. Right. And let me see if you guys know, because I don't want to just show you. And so here's the game plan. How do I figure out the temperature of the biscuits? Well, I know that initially at 0, the temperature of the biscuits is 100 degrees Celsius, right? And it says the temperature of the biscuit is times T small by differential function B. So this is the temperature, the B. So that's your initial temperature. And then this derivative here, this is the temperature, this is my change in temperature, the rate of change, the derivative, in the degrees Celsius per minute. Does that make sense? So if I want to know what the temperature is at 10 minutes for the biscuits, I take my initial temperature and I'm going to add how much my temperature has changed. I guess it's cooling off, so I guess you can push subtract, but just make sure when you integrate, how do I find out how much the biscuits have changed, the temperature? You have to integrate this guy. Because the integral of b of t will tell you how much the temperature has changed. Kind of similar to what we did here. See, the integral of h prime of t will tell you how much the temperature has changed. So maybe that's why, man, this is a good question, whoever the author is. Maybe because he or she warmed you up with letter C for letter B. So if you integrate b prime, that tells you how much it changed, and all you got to do is add it to the 100. Does that make sense? So here we go. I'm going to find the temperature of the biscuits by going 100 plus integral, for which is known, using the given the time t equals 7. Okay, yeah. From 0 to 10 of b prime. I'm going to type that in. Since I'm just using it this one time, I'm just going to go ahead and just type it in like that immediately. I'm going to go math. I'm going to go 100 plus math 9, 0 to 10. And let me type in b prime. Hook me up with the equation, Reese.
It's negative
13.84. E to the power
173.
Negative 0.173 x. And here we go. 34.1827. I'm not surprised. Be careful. Don't put a minus there. Just put plus, and then that integral will take care of the temperature change. 34.18275. I can't believe I forgot. 18275. 18275 degrees Celsius. Okay, we're not done yet. It says, how much cooler are the biscuits than the tea? So take this number. So start a new line, because some of you guys like to go minus whatever. Start a new line. So I'm going to go new line and go 34.18275. And I'm going to subtract the temperature of this tea at 43 at 10 at t equals 10. So how much cooler? So minus, you know what? Absolute value, since I already put 34, because we already know it's cooler. Minus 43. Minus 43, close, equals. So let's see. I'm just going to subtract 10. So I'm going to go 43 minus, Chop, why'd you do 43? I put absolute value, guys, so we're good. It's still the same answer. 8.8172. That's how many degrees cooler. 8.8172. 8172 degrees Celsius. So just write a quick statement. It doesn't have to be fancy. The tea, what's cooler? The tea, no, this guy's cooler, the biscuits. The biscuits are 8.8172 degrees Celsius cooler than the tea at t equals 10 minutes. And there it is, full credit. I'm actually curious to see the rubric on this one. I want to see how they did it. So let me, what year was, they're all 2011. So question 2. Here it is. So letter A was just worth 1 point. Negative 2.666 or negative 2.667. You could also say negative 8/3 is fine. Degree Celsius per minute. They put units there, but they didn't ask, somebody just use changing, show the company. It would have been nice if you put the units. They didn't ask, so I think you'd be fine. Letter B, 52.95. Look at that. They give you 3 points, meaning of expression. They go, this is the average temperature of the tea in degrees Celsius over the 10 minutes. I like the over the 10 minutes. That's fine. No big deal. Trapezoidal sum and the estimate. There it is, guys. Letter C, negative 23. The temperature of the tea drops 23 degrees Celsius from t equals 0 to t equals 10. Degrees drops, cooler, same thing. We got the full credit. Letter D, 8.817. The biscuits are 8.817 degrees Celsius cooler than the tea. There it is. They should have said it at T equals 10, but not a big deal. We got the full credit, guys. All right, we're running ahead of schedule. I thought do I have any BC kids in here? No. I thought we were going to have BC kids here, so that's why I wrote this question here. That was a BC question, but they're not here at the moment. They are going to come, I think. That's what they told me, but I'm going to pause it real quick. All right, here we go with this one. No calculator. It says let R be the region in the first quadrant enclosed by the graph f of x equals 8x cubed and g of x equals sine pi x. So they do give it a name, f and g, as shown in the figure to the right. Write an equation for the line tangent to the graph of f at x equals half. Okay, if I want a tangent line, I need two things. What and what? Point and slope. I already have a point. It's given to you right there. Let me make sure. Okay, there it is. So my point, 1/2, comma 1. And by the way, they didn't have to give us that 1. You could have just plugged in the 1/2 into the x there. 1/2 cubed is 1/8. 1/8 times 8 is 1. And my slope, f prime of x. That's what I need. So I get it from here. So I'm going to write f of x equals 8x cubed. So my derivative, what's 8 times 3? 24x, and then put a... Yeah, that's probably a point. I don't know. I haven't looked at the rubric. And then I'm going to plug in f prime, and I'm plug in a half. So I'm going to go 24, open parenthesis, 1/2, close it, squared. Let's see, 24, parenthesis, 1 times 1 is 1. What's 2 times 2? 4. And then you get 24 over 4. Does that reduce? There it is. That's your slope. Here you go. I'm just going to go y minus 1 equals, what's my slope? 6 parenthesis x minus 1/2. Done. I would not try to simplify that. You can if you want, but be careful that you don't make that mistake, an algebra mistake. Can we do that? Can we do that, Cepeda? Yes, we can, miss. Yes, we can. Si se puede. Oh, do you know Spanish? I don't know. Okay. All right. Find the area of R. All right. What curve's on top? What curve is this one right here? That's a sine pi x, guys. Yeah. Chav, how did you know that was a sine pi x? Well, this is a cubic, and a cubic doesn't, like, see, that kind of looks like it could be a parabola, and I don't have a square. I don't have a quadratic. You know what I mean? So the one that's going down like that, or going through the origin and going down, that has to be your sine. Plus sine is the one that goes to the origin, remember? So this one right here is sine pi x, that's g of x. And this one right here in the bottom, that's your f of x. So find the area of R. I'm going to go integral from what to what? 0 to 1/2. And then what curve's on top again? G of x, and then the f of x is on bottom. On this one, and I'll put the d of x. On this one, guys, yeah, if this were a calculator section, you would just leave it like that. But on this one, since you don't have a calculator, they're going to want you to do the antiderivative. So just go ahead and plug in what the expressions are. Integral, 0 to 1/2. And then the g of x is sine pi x minus your f of x, which is 8x cubed, and then dx. If it bothers you that it just looks like that, just put your parentheses like that. You know, width times height, all that good stuff. But it's understood that the dx is the end of your integrand. How are we feeling right now? I'm going to put an equal sign. I'm going to put a bracket, because that means I'm already going to evaluate this. Antiderivative of sine. Cosine. Is it positive or negative? Let's see. The derivative of sine is cosine. The derivative of cosine is negative sine. So that means the antiderivative of sine has to be negative. Do you guys see that? Leave the inside alone, pi x. Now, chain rule, I would have multiplied this by pi, but I'm not taking a derivative. I'm taking an antiderivative. So instead of multiplying by pi, I'm going to divide. An easy way to remember this, guys, is whatever linear expression you have on the inside, just take the reciprocal. Like, see, the derivative is pi x, take the reciprocal, 1 over pi. That make sense? Okay, let's make sure we get that point. All right, so there it is. I think we're good there. And then minus antiderivative of 8x cubed, add 1 to the power, that's 4, and divide by 4. What's 8 divided by 4? 2x to the 4th. Close it. Lower limit 0, upper limit half, equals negative 1 over pi. I'm doing, yeah, let me put a bracket here and parentheses. So I'm doing upper minus lower, guys. So I'm going to open up a parenthesis. I'll color code the parentheses. Use your pens. Use your pens on the AP exam. Negative 1 over pi cosine of, I'm putting in a half in there, so pi over 2. Close it, minus 2 times 1 half. Close it to the 4th power. And I'm going to close it with a blue. Minus, and then open another one with a blue. And then I'm going to type in, again, negative 1 over pi cosine parenthesis, and I'm going to plug in the 0. So it's going to be 0, close, minus, oh, this one, I guess you don't have to do this one right here, 0 to the 4th. Okay, I hate to say this because I actually do want you to. If you're scared, Chop, I can leave the cosine power 2 and the cosine 0 unsimplified. If you are scared, will this be full credit? It will. You can leave this as cosine power 2. You can leave this as cosine 0. Now, okay, maybe I shouldn't say this. If you just care about the point, you can stop right there. I really do want you to simplify this because your professor is probably going to want you to do that. Imagine a patient that needs a heart transplant or needs a heart, and you just stop right when you put the heart in. Like, no, I'm not going to sew you up. You got your heart. Like, come on, like, you know, like, finish it. You're going to be the next doctor. You're going to be the next lawyer. All right. Sorry. That maybe that example was too broad here. Equals. All right. Let's see. Cosine power 2 is 0, so that goes away. 1 half to the 4th power. So let's see. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And then times negative 2. So I see a negative 1/8. Negative 1/8 on that first one. I see a negative 1/8 here on that one. Let me know. I make mistakes all the time. And on this one, I see minus, and then I see cosine of 0 is 1, so negative 1 over pi. So I see plus, so negative, so plus 1 over pi. So here's the answer that I see. I see a negative 1/8 plus 1 over pi. I hope we are right. It would suck if I'm wrong, if we're wrong. But that's what I see. We'll check right now with the rubric. We're still okay, guys? Okay, let's see what letter C says. Write, but do not evaluate an integral expression for the volume of the solid generated when R is rotated about the horizontal line y equals 1. Okay, so I'm going to rotate this. I'm going to come up here, and I'm going to erase all this stuff here. And I'm going to rotate it. So I wouldn't bother redrawing it, guys, because you don't have that much time. I would just go like literally just like that, and then I would just try to, let's see, I'm going to say that point's there, and look something like, it's not going to be perfect, which is fine. And then this point, it's not perfect. That's okay. And I'm rotating it about that. So look, when I slice it, what shape is that? A washer. Here it is. I'm going to zoom out so I can see it. Volume equals, and do I have to evaluate it? No, probably because you do not have a calculator. And this is way too, it might be a complicated integral. Pi, integral, from 0 all the way to half, open parenthesis, big R. So the big R is a distance from the axis of rotation, 1, all the way to this bottom curve. So this one here in violet. This one here in violet, that's your big R. Is that violet or is that purple? Okay, so what is that distance? 1. I'll color code it. 1 minus whatever that curve is down there. And we said that curve down there was, did we say that was g of x? No, that was f of x. Minus f of x. And there it is. Close it, put a square on it. Minus, open parenthesis, and then this one here in blue. No, do it in black. This one here in black, that's little r. So that is 1 minus g of x. 1 minus g of x squared, and then there it is. We're done, guys. Leave it alone. Should we look at this rubric, see how we did? All right. Let's look at this rubric. Yep, I knew it. Check it out, Cepeda. They give you a point for the derivative at half. So we can do this, guys. I'm telling you. And then the answer, yeah, we got that answer. We didn't leave it like that. We did y minus 1, but that's the same thing. Letter B, they did that. Perfect. That's what we did. Boom. Negative 1/8 plus 1 over pi. That's our answer. We got it. We got it, guys. Wow. I was thinking that was going to be a 3-pointer. They give you 4 points for that. 1 point for each antiderivative. Boom and boom. That's cool. That's cool. I'm happy. I'm happy. And then letter C with a 3-pointer. 1 for the limits and constant and 2 for the integrand. You don't have to write it 8x cubed. You're perfectly fine with the top line right here. 1 minus f of x with a square on it. 1 minus g of x with a square on it. Pi on the outside, 0 to half. So we can do this, guys. What do you guys think? All right, look at us. We're ahead of schedule. I'll go ahead and upload this for someone get. All right, this one. Hey guys, the original audio video that I had here got corrupted somehow. Like I don't know what's going on. It just like the audio recorded, but the video part didn't record, and it was just stuck on a screen. So here I am doing it again. I found out that it didn't record when I went to go play it back. So I don't know what's going on with my laptop. I don't know why my laptop has done this from time to time. All right, let's get right into it. Hopefully, I know that I'm already warmed up because I've already done this question, but I'll try not to do it too fast, and I'll hopefully maybe this time I can explain things better. So here we go. So this is from the ABBC question 4. This is a common question from both exams. The continuous function f is defined on the interval -4 to 3. The graph of f consists of 2 quarter circles and 1 line segment. So here's one of the quarter circles. It's a smaller radius. It has a radius of 1. And here's the other larger quarter circle that has a radius of 3 there. All right, let's see. As shown in the figure to the right, let g of x equals this expression. And notice I have a 2x there, integral 0 to x of f of t dt. Find g of -3, find g prime of x, and evaluate g prime of -3. So here we go. G of -3 equals 2 times -3 plus integral from 0 to 3, -3, sorry, 0 to -3 of f of t dt. Okay, so this part right here that I'm putting in a bracket, that is just area into that curve, right? And it's this curve right here. Here's 0. So I'm finding this right here. And so that you're just going to find the area. It's just a quarter circle. So area of a circle is pi r squared. So I'm going to go 1/4 pi r squared. The radius, 1, 2, 3. I guess you could also go on the x-axis there. So here we go. Now remember, guys, I'm starting at 0 and I'm ending at -3. So you're going to count backwards. So I'm going to go -6. That -6 is this guy. Plus bracket. And it's just the area of this, pi r squared divided by 4. And remember, we're counting backwards, so we're going to put a negative on the outside because, yes, the area is above the x-axis, but I'm counting backwards from 0 to -3. So since it's above the x-axis, I'm going to put negative, and I'm going to go pi, and then the radius is 3, so 3 squared divided by 4 because it's a quarter of a circle. So what's my answer? -6 minus 9 pi over 4. And there it is. Leave it alone. All right. G prime of x. So g prime of x, I'm going to take the derivative of this guy. Derivative of 2x is 2. Plus, and then I have an x on the upper limit. I have a constant on the bottom. The derivative of that integral is simply the argument itself, which you have on the inside, f of x. So I'm going to write g prime of -3. So that's going to be 2 plus f of -3. And I notice 1, 2, -3. Sorry, guys. I need to sneeze. If you were wondering why I'm so quiet. It went away. I had to sneeze, but then it just stopped. 2 plus f of -3, that's a 0. So 2 plus 0, so just 2. And I think we got everything. Let's see. Boom, boom, and boom. 3 booms. Yeah! Sorry, I hope I didn't bust your eardrum there. Determine the x-coordinate of the point at which g has an absolute max on the interval -4 to 3. So I have an absolute max whenever the derivative changes from positive to negative. The derivative of g, right? So here we go. I'm going to take my g prime of x, and it's going to equal to 2 plus f of x. And I'm going to equal it to 0 because that's the only way I'm going to go from positive to negative, right? And of course, you also got to test your endpoints, but not in this case because I noticed The only way I can get that derivative to equal 0 is if f of x equals -2. So negative f of x, this is f of x right here, guys. -2 is down here. That's your equation. That's your equation. That's where f of x is -2. So I want you to think about what g prime of x looks like. It's f of x, which is this guy right here, and that 2 is a vertical shift up 2. Vertical shift of f of x up 2. So it's this graph shifted up 2 units. So if I do that, if I shift this graph up twice, this f of x equals -2 would be right on the x-axis. So this is like an x-axis. It behaves like an x-axis for g prime, right? So that means g prime, notice, this is the only time I cross that. G prime is positive from -4 all the way to wherever this intersects, and then only then, and only then, do I go below this line, which means I'm changing from positive to negative, because this is like an x-axis. It's like an x-axis. So I hope you understand that. If you don't, please put a comment, and I'll try to be more specific, or I'll try to explain it better. So yeah, guys. So there it is. So I must have an absolute maximum at that exact point, because it's the only point on the entire interval where the derivative changes from positive to negative. Right at -4, my derivative is positive. It's above this line here, and it's always above that line forever and ever and ever until I reach that x value. What x value is that? Well, let's see. 1, 2, 3, 4, 5. 1, 2, 3. No, I'm not going there. I'm going to the 3, -3. 3 down, 3, 6 down, 3 right. So my slope is -2, and 1, 2, 3. So this equation is y equals -2x plus 3. And I'm going to set that equal to -2, because that's what I want to do. I want to figure out where this line equals -2, because that's the x value. So here it is, equals -2. Guys, this equation, that -2x plus 3, that's this line right there. And that -2 is what I want to figure out. I want to figure out where this function intersects that -2. -2x equals -5 divided by -2, x equals 5/2. So that is the value where g prime is changing from positive to negative. So I'm going to write absolute max occurs at x equals 5/2, because on the interval what? -4 to 5/2, g prime of x is positive, and on the interval 5/2 to 3, g prime of x is negative. Hence, absolute max must occur at x equals 5/2. I hope that made sense, guys. I know there was a lot in that little thing. I feel like I explained it better in class than I did right now. Well, let me drink some water real quick. Oh man, I was thirsty, guys. So yeah, let me know if that made sense. Find all values of x on the interval between -4 and 3 for which the graph of g has a point of inflection. G has a point of inflection whenever the second derivative of g changes signs. So I'm going to write right here, g prime prime of x is equal to, and here's my g prime, so it's going to equal to f prime of x. And I have f, so all I got to do is check where f prime changes from positive to negative. Did I say that right? Yeah, I said it right. Where g prime changes from positive to negative. So g prime prime, so let's see, this is f. So f prime, let's see, I'm increasing. So f prime is positive, 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 undefined for a moment. Positive, 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 boom, 0, and then negative. So there it is, right there. That's the only point. Guys. So I'm going to write the graph of g has a point of inflection at x equals 0, since g prime prime, which equals f prime, changes from positive to negative. Oh, hold on, it just stopped. Oh, there it is. It was just behind. From positive to negative at x equals 0. Let me see if that makes sense. The graph of g at the point of inflection at x equals 0 says g prime prime, which equals f prime, changes from positive to negative at x equals 0. Yeah, no, that's enough. That's it. We're good. And yeah, that's it. I don't see any other issues. I think we're good, guys. Find the average rate of change of f on the interval negative 4 to 3. There is a point C between negative 4 and 3 for which f prime is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem. Let me read that again. There is no point on this interval for which f prime of C is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem. Mean value theorem is f prime of C equals f of B minus f of A over B minus A. And you have to be continuous on the closed and differentiable on the open. So let's see if, first let's find the average rate of change, right? So f of 3 minus f of negative 4 over 3 minus a negative 4. So f of 3 is negative 3 minus f of negative 4 is negative 1 over 3 plus 4, 4, 5, 6, 7. 3 minus negative 1, so plus 1, so negative 2. So there's my average rate of change. Now, let's see. Mean value theorem. So I need to check that I'm differentiable and that I'm continuous. I am continuous, but you are not differentiable right there because that's a vertical tangent, and you're not differentiable at x equals 0 because you have a corner. So mean value theorem does not apply to f. Mean value theorem does not apply to f since f is not differentiable on x equals negative 3 and x equals 0. And there it is, guys. I felt I was a little fast on this one. I feel like I did a better job in the classroom on this one this Saturday morning. But yeah, let's go look at the scoring guidelines. College Board response. Well, it doesn't matter, A, B, or B, C. It's the same. 2011 scoring guidelines. All right, so here it is. And yeah, negative 6 minus 9 pi over 4. G prime 2 plus f of x. G prime negative 3 is 2. We got those points, guys. G prime is 0 when f of x is negative 2. This occurs at 5 over 2. Maybe there's a faster way to get that 5 over 2. Maybe I guess you could just find the slope, which... Oh, sorry. I've been up pretty early today. Which is negative 2. And then, yeah, I mean... I found it by finding this equation of that line and then just seeing where that equaled negative 2. But yeah, there it is. And then g prime is positive on that interval between negative 4 and 5 halves. G prime is negative 5 halves to 3. Therefore, g has an absolute max at x equals 5 over 2. We pretty much said the same thing. G prime prime equals f prime, change the sign only at x equals 0. Thus, the graph g has a point of inflection at x equals 0. Perfect. And the average rate of change, negative 2, 7. To apply the mean, f must be differentiable at each point on the interval, negative 4 to 3. However, f is not differentiable at negative 3 and 0. Yeah, there it is. I feel like we got full. We got the full credit there. We ate. So yeah, there it is, guys. All right, let's. I'm gonna take a little break and then I'm gonna continue. I'm gonna do some pre-cal questions first, and then we'll do the BC questions last. All right, later. Bye. All right, guys, here we go. Now we're going to do a pre-cal question. Yes, I had already done it this morning, but it didn't record. I think the file got corrupted somehow. The audio recorded, but the video didn't, which is weird, right? So let's continue. Let's continue. Hopefully, I don't go too fast because I'm kind of already warmed up here. All right, it says all these questions, I don't know any of them, guys. They're from the actual release AP exam from College Board that the College Board releases. It's on their website. This is question 1 from College Board, and it says, the figure shows the graph of the function f on its domain, negative 3.5 to 3.5. The point negative 3, 1, 0, 1, and 3, 1 are on the graph of f. The function g is given by g of x equals 2.916 times 0.7 to the power x. So the first thing I would do, you're probably going to need this guy. I'll put that in y1. The function h is defined for g composite of f, and so this means f is inside of g composite of f. Find the value of h of 3 of the decimal approximation, or indicate that it is not defined. All right, so let's do that. So I'm going to go h of 3, and that's going to equal g of f of 3. And well, f of 3, I'm going to come here to the side. F of 3 is 1. That was given. So this means that this is g of 1. So I'm gonna go to the side here, and I'm gonna go g of 1 equals, and I know what g is. G is this expression here, 2.916 times 0.7 to the power 1. And so I'm gonna take my calculator, and I'm gonna type that in. I'm gonna go 2.916 times 0.7, because 0.7 to the power 1 is just 0.7. And there it is, 2.0412. 2.0412. You could have also typed this in, like I said, I typed that into y1, guys. So if you type that into y1, and I already forgot the 2.916. 2.916 times 0.7 to the power x. And there it is. And I could have gone to the home screen, and I could have just gone alpha trace y1 evaluated at 1, and voila. So there it is. 2 ways to do it. And let's go to the next one. Or maybe I would make a statement here that h of 3 is nothing more than 2.0412. All right. Find all values of x for which f of x equals 1, or indicate that there are no such values. It does say f of x equals 1. This is f, and if I draw a line right at 1, look what happens. There's 3 of them. 1, 2, 3. And it's also the point that they gave you there too. So I'm going to go f of x equals 1. This is called the setup. So f of x equals 1. Where does it equal 1? At x equals negative 3, comma, at x equals 0, comma, and at x equals 3. And there it is, done. And then find all values of x as decimal approximation for which g of x equals 2. So I want to know where g of x is equal to 2. So I'm going to come back. I'm going to write that expression. I'm going to go 2.2. Oh, man, I'm tired already, guys. 2.916 times 0.7 to the power x. I'm going to equal that to 2. And you can do this by hand. I did it by hand during class. But I think the best route is to type this on y1 and type that on y2. And see where they intersect. So this is called the setup, and I'm just going to give you the answer just here on the side there. So I'm going to take my calculator. I'm going to go to the y equals. You can also do this with Desmos. So there's my y1. I'm going to go to 2 there. I'm going to click window, and I'm going to go 0 to 6 because that's the domain. Or wait, actually the domain of this is all real numbers, but I figure function f is domain. Okay, so you can leave it. If you know how that exponential looks, I don't know why I'm getting 0 to 6. I'm thinking of maybe of a calculus problem. Maybe the last one was 0 to 6. I'm going to leave it negative 10 to 10 because I think that's by default how it looks. I'm tired, guys. Like I said, well, I'm making so many mistakes today. Or this evening. I think I was pretty good this morning. So there it is, negative 10 to 10. I'm going to push graph. And there it is right there. And I'm going to find that intersection. And the way you do that, guys, you just tell the calculator to give you the intersection value by going second, and then you'll see the little says calculate, so second calculate. And these are all the things that your calculator can do. I'm going to put number 5, intersect. You only have 2 curves in there, so you can just push enter, enter, enter. See, y equals 2 there is the second curve. And then guess. If there were several intersections, you go to the one that you want. There's only one, so I don't have to guess. I can just push enter. And there it is. 1.057168. So I'm just going to type in 1 point, and I already forgot. 1.0571688. 1.0571688. So 1.0571688. Yep, that's it. I don't see any issue there, and I think we're done. Like I said, you could have done it by hand. Divide by 2.916. Do ln. You could have done this. Divide, because that's a product there. So you could have said 0.7 to the power x equals 2 over 2.916. And then you could have brought ln in to bring the x down. ln, the power rule for logarithms. You could also say log. And then you would have x ln of 0.7 equals ln of 2 over 2.916. And then just divide by both sides, right? So you can go x equals ln of 2 over 2.916 divided by ln of 0.7. You could also use your change of base rules for writing it like this if you want. X equals log base 7, log base 0.7 of 2 over 2.916. And that would work as well, which should be 1.0571688. Let's see. So second quit, math, log base 0.7 alpha equals 2.916. I think it was 916. 916, yeah. And enter. There it is. 1.057168831. Oh, look, more digits. More accurate. 31. The more accurate, the better. They did say decimal approximation, guys, so give them a decimal approximation. Don't leave it in terms of ln or log. All right. Determine the end behavior for g as x increases without bound. Express your answer as using the mathematical notation of a limit. Well, it's already, you have it here, guys, in the graph. Hopefully you already know that. That's a graph in blue. That's your exponential. So see what it's approaching. It's approaching 0. It's approaching 0 because look what it is. It's 0.7 raised to the power x. It's a number between 0 and 1, and if you keep making x larger and larger, the output of this will keep getting smaller and smaller. Not forever. It's gonna. When I may say smaller and smaller, it's approaching the value 0 because technically negative 10 is smaller than 0, negative 100 is smaller than negative 10. So you're getting smaller and smaller towards amplitude of 0. So there it is. So the way you write this, you write limit as x approaches infinity. So there it is. That's as x increases of the function g of x, and that's going to equal 0. You can also say arrow 0, but it's better that way. All right, determine if f has an inverse. So here's f, and remember they made such a big deal about this repeated value, about these ones here. Remember that when you're finding your inverse, your x and y switch. And so if your x and y were to switch, you would have 1, -3, 1, 0, 1, 3, and you can't have multiple y values for the same x. And for it to be a function, you need to have one y for an input. So no, f does not have a function. F does not have an inverse function. An inverse function. Because f itself is a function, but it does not have an inverse function. And it says, give a reason for your answer based on the definition of function on the graph of y equals f of x. I'm going to write since f of -3 equals 1, comma, f of 0 equals 1. I think it was f of 0, yeah. Comma, and f of 3 equals 1, comma, f will not have an inverse function since x's can't repeat. Since x's can't repeat. Since x's can't repeat. what I mean by that, guys, is I would have this f of inverse f of 1 equals -3, inverse f of 1 equals 0, and inverse f, that looks like a derivative there, -1. Inverse f of 1 equals 3, and we can't have that. We can't have the x's we can't have the same x give you different y values. It's not, you can't make a prediction now. So that's why you can't, f does not have an inverse. Since f of 3 equals -1, f of 0 equals 1, f of 3 equals 1, f will not have an inverse function since x's can't repeat by definition. By definition of a function. Hopefully I'm being specific enough. I did say f will not have an inverse function since x's can't repeat by definition. Inverse function, yeah, I feel like I'm being specific enough. And then I put here, see the definite, like there, if I put a 1, I get a -3. If I put a 1, I get a 0. If I put a 1, I get a 3. So you can't have that. You can't have x's repeating. So maybe I feel like I did a better job in class today, but let's see what the rubric has it down. Let's see, this is 2004, and I don't think I saved the rubric, so we're gonna have to look for it real quick. Now, hopefully, it's already highlighted in my browser because that's we did this already. It's part of the browser history here. So let's see, AP. There it is. See, so I had already looked it up, and yeah, you can tell it's already. I clicked on it already, and for response questions. Nope, not the questions. I need the scoring guidelines. Scoring guidelines. And here it is, guys. So here's question 1. And we got all the points, but I just want you guys to see it. 2.041 from the graph of f, 1 and negative. When this function is 1, x is -3, 0, and 3. We got that, so we got those points. Every free response question is worth 6 points, guys. There it is. We got those. We got that. So there, we got all of them. And here it is. So f does not have an inverse function. That's the point. There are output values of f that are not mapped from a unique input values, for example. So yeah, I think they maybe they made it sound better. And I know maybe you're saying, Chop, why even write inverse if I don't have an inverse function? You can have an expression though, and that expression doesn't have to be a function. So I think I'm okay writing that. I don't see any issue. If you're paranoid, I guess if you're paranoid, you can choose not to write it, and I think you'd be okay with what we wrote. I think we'd be okay with what we wrote up there, and I think we'd be fine. And that's exactly what they wrote in their rubric too. So yeah. All right, guys, here we go from the 2024 exam, question 2. This is a pre-cal question. It says, on the initial day of sales, that was t equals 0, the initial day, for a new video game, there were 40,000 units of the game sold that day. So since they're spelling it like this, 40,000, instead of saying 40,000, they probably want you to just use the number 40 there. 91 days later, and so t equals 91, excuse me, there were 76,000 units of the game sold that day. The number of units of the video game sold on a given day can be modeled by the function g, given by g of t equals that, where g of t is the number of units sold in thousands on day t since the initial day of sales. All right, letter A. Use the given data to write 2 equations that can be used to model to find the values for constants a and b in the expression for g of t. Well, guys, look, you already have, so let me turn this into a tablet here. You already have everything you need. Sorry. So the points that you're going to be using are the points 0, 40. And the next point is going to be 91, 76. So those are the 2 points that we're going to be using, guys. So there we go. So let's use them. Remember, this is your t, your time, and this is how many games have been sold. So that's your g, g of t, I guess, if you want to call it that. G of 0 actually is the better term because that's the output when the time is 0. So this is your t, and this is g of 91. All right, so here we go. Here's my equation. It's this one right here, and I'm just going to plug in equation number 1. The output 40 equals a plus b ln of 0 plus 1. In the second equation, remember guys, you still have a calculator. Your second equation is 76 equals a plus b ln of your t is 91, so 91 plus 1. And there it is, guys. Find the values for a and b as decimal approximations. Okay, well, the first equation, equation 1, notice it says ln of 1 here, so hopefully we all know that. 40 equals a plus b ln of 1. Ln of 1 is 0, guys. And 0 times anything is 0, so 0 times b is 0, so that's going to go away, and you're just going to have 40 equals a. So there it is. Use that to substitute into equation 2. So equation 2, I'm going to bring that a, and here we go. So I'm going to have 76 equals 40 plus b ln, and then when you add these two numbers up, that's 92. And then you're trying to get b by itself, so you're going to go minus 40, 40, 50, 60, 70, so that's 36 equals b ln of 92. And then divide both sides by ln of 92. ln of 92 divided by ln of 92, and you get b equals 36 divided by ln of 92, and that's a number. So let's take our calculators. So here's my calculator, and we're going to go second quit, and we're going to go 36 divided by ln of 92. You can also use a little fraction feature, guys. That's not a big deal if you want to use the fraction feature. 36 divided by ln of 92. Hopefully I didn't make any mistake there. And voila, 7.96145. B equals 7.96145. That's a 9. And there it is, 96145. There's your A, there's your B. And we got them. So from there we have an equation. Well, if you have space, you can write out your expression. I have space right here, so I'm going to write y equals, well, not y, g of t. G of t equals A, which is 40, plus 7.96145 ln of t plus 1. There's your equation. And I put it a different color, guys, to differentiate from the red there. All right, here we go. Use the given data to find the average rate of change of the number of units of the video games sold in thousands per day from t equals 0 to t equals 91. Express your answer of the decimal approximation showing the calculations that lead to your answer. All right, so here we go. So you're just doing an average rate of change, guys. So you're going to do g of 91 minus g of 0 over 91 minus 0. So g of 91, well, you already know that. G of 91 is 76. So we're going to go 76 minus, and then g of 0 is 40. So 76 minus 40 over, and then the bottom is just 91 minus 0. So let's see what that is. So 40, 50, 60, 70, so that's 36 divided by 91, and let's see what that is. So I'll take my little calculator, and I'm going to go 36 divided by 91, and we get this, 0.3956. 0.3956. 0.3956. So there it is. That's my rate of change. Use the given data to find the average rate of number of units of video games sold in thousands per day. So there it is. Thousands per day. Thousands. Can I spell? Thousands per day. And that's done. We're good. Let's see. This one says use the average rate of change found in 1 to estimate the number of units of the video game sold in thousands on day t equals 50. So this means get your secant line. Get secant. So we're going to use y minus y1 equals slope, x minus x1. So here we go, guys. I'm going to go, you can use any point, but you probably want to use 0.40 because the 0 sometimes makes things easier. You can use a 91.76. We're talking about the same line anyways. So it would give you the same answer. So I'm going to go y minus 40, because that's what I'm using, the point 0.40, guys, equals, and then my slope is that, 0.3956. Use more digits as possible. X minus 0. That's actually your t, and this is actually your g, right? We're using this to approximate. And then it wants us to know how many are on day 50, so plug in a 50 in there. So I'm going to go, let's see, y equals 0.3956. Use a number on your calculator. Use calculator, and don't round into the very end. 50 minus 0, that's 50. I'm just plugging in 50. Just plugging in 50 right there. And then remember, we move that 40 to the other side, so plus 40. So take your calculator, and we're going to go that number right there times 50. And then we're going to go plus 40. And there it is, 59.78021. 59.78021. Hopefully I got all those digits right. 78021. Yep, there it is, guys. And that's approximately in thousands. That's approximately how many games were sold. I think we're good. Let's keep going. Let A of T represent the estimate. Let A of T represent the estimate of the number of units of the new game sold in thousands using the average rate of change found in 1. So that means this equation right here. For A of 50 found in 2, it can be shown that A of 50 is less than G of 50. A subscript of 50, I should be saying. Explain why in general G of T is bigger than A of T for all T's. Well, guys, this is a logarithm function. See? So your logarithm function is always going to be bigger because remember your logarithm functions, if I were to tell you graph y equals ln of x, and by the way, ln is just a log with a base e, right? So if I were to tell you graph y equals ln of x, remember that it looks like this. And so all logs are concave, what would you call that? Concave up, concave down? That's concave down, right? So because all logs are concave down, if you draw a secant line, a secant line is going to be an under approximate within the interval of the points that you use to get your secant. So check it out. I'm going to plug this equation. I'm going to plug this into your calculator. So let me see if I can. I don't want to type all those digits there. So I'm going to see if I can store that to like a letter, alpha A, or maybe I should use B because we're using A. So there it is. There's my B. You don't have to do it like this, guys. You don't have to do it like this, period. So I'm going to type in my original equation, the ln that I got. So 40 plus, and I already forgot. I'm typing in this one in the blue. 7.96145. 7.96145 ln x plus 1. And then on this one, I'm going to type in, I guess I could start off by saying 40 as well again, but I'm going to go A or B times x plus 40. And that's where I save the slope. B times x plus 40. You don't have to put B. You can put all the decimal digits. And then look what happens when I graph. Oh, yeah. It's not going to show up in there because I'm way up there at 40, guys. Window. Let's go to 100. And at y scale by 10. All right, graph. Look what's going on. So let's go ahead and look at it between 0 and 20 or 15. And you can see what's happening. Well, maybe it's not maybe I should, let me go to 50. Yeah, because the other one was 70, right? Or 91. So let's go to 100 then. And make x scale by 10. There we go. That's better. Look what's going on. Concave down. And look at this line right here, this red line. This is my secant line. And that secant line is below the curve. It's below your model equation here. See? So it's going to be an underestimate. So that's what they're talking about. So this is why they said this, that G of 50 is bigger than the estimated one. And they're telling you, in general, why is G of T always bigger than A of T for all T between 0 and 91? So that's because your secant line is below the curve. So I'm going to write, since G of T is concave down, and since we used comma 0 comma 40 and comma 91 comma was it 76? Yeah, 76 to form A of T, or A of T, A subscript of T, comma, A of T is below the curve g of t on this specific interval. Did I mention it was? Yeah, since g of t is calculated down, and since we use 0, 40, and 9176 to form a of t is below the curve g of t on this specific interval. Perfect. And you can see it. You can see how it's always below. And then as soon as you pass this point right there, that's at 91, then obviously the secant line is above the curve. But we're not talking about that. We're talking about within this interval here, guys. So hopefully that's making sense to you guys. Let's continue. The makers of the video game reported that daily sales of video games decrease each day after t equals 91. Okay. Explain why the error in the model G increases after t equals 91. Well, this is perfect, guys. G of t is always increasing. Look, the G of t is a blue curve. It's always going up. But they're already telling you that the cells start decreasing. So we're going to say G of t is always increasing in its entire domain. And I'm going to say, and I'm just going to use their language. The video game reported that daily sales of the video game decrease each day after t equals 91. Since the daily sales decreased each day after t equals 91, comma, each day that passes after t equals 91 will have a greater and greater error. And then maybe put in parentheses, g of t is increasing, comma, cells are decreasing. I hope that's specific enough. Let me read it again. G of t is always increasing in its entire domain since the daily cells decrease each day after t equals 91. Each day that passes after t equals 91 will have a greater and greater error. G of t is increasing, cells are decreasing. I think that sounds good, guys. All right. So there it is. We've done 4AB, and well, out of the 4AB, 2 of them have been BC. And hopefully you guys understood those 2 questions for Precal. And yeah, let me know. Keep me in the loop. All right, BC crew. Here we go. We got 1 question. Well, we got 2 questions from BC that we're going to work on right now. And let me know what you guys think of it. I think they're pretty good questions. I like them. So hopefully you like them as well. And let's go right into it. At time t, a particle moving in the xy plane is at position x, y, where x and y are not explicitly given. For t greater than or equal to 0, dx dt is 4t plus 1. So immediately I would type that into your y1 of the calculator, and I would type this into your y2 of the calculator. At time t equals 0, x is 0 is 0, and y is 0 is negative 4. So your initial position is 0, negative 4. That's an x value. This is a y value. And that happens when t is 0. All right, find the speed of the particle at time t equals 3 and find the acceleration vector of the particle at time t equals 3. All right, no big deal. It's a calculator active. First thing I'm going to do is type that into y1 and this into y2. I don't necessarily need it, but I'm going to be recalling it all the time. So 4t plus 1, y1. Okay, so let's click there. I'm going to go y equals, let me reset this thing. 7, 1, 2, y equals, and I already forgot, guys. So let me, 4x plus 1, okay? 4x plus 1, enter, and then y2, sine of x squared. So sine of x squared. All right, there it is, y1 and y2. Second quit. And so let's see. Let's do the first question again now. Find the speed of the particle at time t equals 3. All right, so I want speed, so I'm going to write speed at t equals 3 equals the square root. I have my dx dt here, so I'm going to write dx dt evaluated at t equals 3, close it squared, plus dy dt evaluated at t equals 3, close it squared, equals, and I'm going to write the answer there. So I'm going to get my calculator, and I'm going to go square root, and then remember I already have it in y1 and y2, So alpha trace y1, I'm going to put parenthesis 3. And I should have put parentheses from the beginning. You're probably safe just typing in a square there, but I'm like super paranoid here, so I like to just do that like that. See, so there it is, y1 of 3, whatever that is, square it, plus, and I have the speed, the y speed in y2. Well, again, let me open up a parenthesis before I forget. Parenthesis, oh, no, parenthesis, and then alpha trace y2, and then again evaluate it at 3, and I'm going to close this and I'm going to put a square on it. All right, I think we're good. I'm going to push enter, and there it is, 13.00653. 13.00653. 13.00653. All right, there's my speed, and they want the acceleration vector of the particle at t equals 3. So that means my derivative. So take the derivative. So your acceleration vector first, right? And then we'll go ahead and plug in a 3. I guess we could have just done it immediately. The derivative of 4t plus 1 is just 4. And the derivative of sine t squared, let's see. So the derivative of sine is cosine, and we got to keep the t squared. And then the derivative of t squared is 2t, so chain rule, so 2t. So there's my acceleration vector. Now I'm going to plug in the 3. So acceleration at 3 is equal to chevron 4 comma, and just plug in a 3. I guess you could have also done, you could have done it in the calculator, right? Because y2 is what you have there. So you could have just done this. I'll verify that it's the same thing. 2 times 3 is 6, and then cosine of 3 squared is 9. So 6 cosine 9, and enter. So we got that. And but watch, it would have been the same thing, guys. Math, and then number 8 derivative respect to x, and then alpha trace y2, and then plug in a 3 right here. And look, we got the same. I know what you're saying, child. After the 7, it's 8. It should have been an 815, and this one has 512. What's going on? There's just it's the programming thing, like your tolerance levels and all that. So when you guys become programmers, you guys can tackle that battle. But yeah, it's the same to the 7, so I'm gonna write that negative 5.4667. Oh, I can hear my little sister. If you hear my little sister in the background, she's just in the room next door, talking to her crew, talking probably smack maybe. Yeah, because she's a gamer. Negative 5.4667. That's what I'm gonna put. So negative 5.4667. And there it is. All right. Find the slope of the line tangent to the path of the particle at t equals 3. So guys, slope is always the same thing. Dy dx is always going to be slope. So dy dx evaluated at t equals 3. That means I need to get my dy dt at t equals 3. And I'm going to divide it by your dx dt at t equals 3. When you do that, notice the t's cancel out and you get your dy dx. So let's see what that is. Remember, I already have this one in your y2 of my calculator, and I have the denominator, the dx dt, in your y1 of my calculator. So I'm going to take my calculator. I'm going to go alpha y equals enter, and I'm just going to type in the y2, because that's my dy dt, alpha trace y2 here, and I'm going to plug in open parenthesis 3, close it, and in the bottom, I'm going to go alpha trace y1, and I'm going to plug in a 3. And there it is, 0.03170. 0.03170. 0.03170. All right. Find the position of the particle at time t equals 3. All right. So if I want position, it's the same as when you were in AB, guys. You're just finding your initial position and you're adding displacement. So I'm going to write my position at 3 for x is equal to my initial position, which is 0. So 0 plus the displacement, so integral from 0 to 3. And this is just me. I'm not a big fan of writing dx dt with the dt. So I just like to put the expression in there. 4t plus 1 dt. So let's see what that is. I'm going to type it into the calculator. There's no need to do it. I already have this in your y1. And since I have 0 there, I'm just going to go 0 plus math 9. And I saw that it was a linear line. We can probably do it real quick with just geometry there, right? But I'm just going to just type it in like this. Alpha trace y1. Put an x in there. Push enter. 21. So that equals 21. All right, here we go. Y3 equals, my initial position in the y value was negative 4. So negative 4 plus integral from 0 to 3 of your dy dt. So sine t squared dt. I don't see any issues, so here we go. I'm going to go negative 4 plus math 9 from 0 to 3. And I'm going to type in alpha trace y2, and then put an x here on the outside, and then there it is, negative 3.22643. Negative 3.22643. Hopefully I did that correctly. Just find the position of the particle at t equals 3, and I'm going to write at t equals 3, particle is at, and then just write the ordered pair, 21 comma negative 3.22643. And there it is. We're done, guys. All right. Find the total distance traveled by the particle over the time interval 0 to 3. Again, it's just really just adding up an infinite amount of Pythagorean theorems. So here we go. I'm just going to go total distance. Oh, I don't know if you heard what my sister said there. I hope you didn't hear it. Maybe if you enhance the audio, you'll hear that, what she said. But disregard. Area from 0, see, she got me all flustered now. From t equals 0 to t equals 3, and then I'm going to write the square root, and then I'm going to write dx dt, close it squared, plus, don't evaluate it at 3, just dx dt like that, dy dt, close it squared, and then put a dt on the outside, and then use your calculator, guys. So here we go. Math number 9, 0, was it 0 to 3? I can't remember. Oh yeah, 0 to 3. So 0 to 3, come back in there. I'm going to go second square root, alpha trace y1 squared. I think we're safe there. Plus alpha trace y2, because that's your dy dt. Put a square on it. And just put an x right here. Oh, no, not right there. Right here. Push enter. And there it is, 21.0911. 21.0911. 21.0911. And is that it for this question? All right, guys, so let's look at this BC question 1 and see how we did. So let me take out the scoring guidelines. And I think I was just looking at them earlier. Yeah, here it is. And let's see what it says. This one is question 2. No, question 1. So there it is, 13.006 or 13.007. I think that's what we got. 13.006, yep. And 2 points, 4 comma negative 5.467. I think that's what we got. Yeah, 5.467. Everything looks good. 0.031 or 0.032. We got that point. 0.031. Good job. 21 and negative 3.226. Yeah, it looks exactly the same. 21. Yeah, we got it down, guys. It's going to be looking pretty much. Your answers will probably look almost identical to this key there. Most of these are just, that's just the way it works. That's the way cookie crumbles. And yeah, we're good. All right, let's do one more. Let's go all the way. Yeah, look at all the questions we've done. I know we haven't done it in order. So I'm sorry if that irks you guys. This one right here. So let's do this last one, and then we'll call it a day, and we'll upload this, and we'll be done. All right, from the 2011 BC Q3, let f of x equals, there's no calculator, guys, so let me go ahead and turn off my calculator. So we're done with the calculator. So let me get this out of here. All right, so that calculator is done. I'm going to leave this. I'm going to minimize that because we're going to need that later on. All right, so let's see. It says, let f of x equals e to the 2x. Let R be the region in the first quadrant bounded by the graph of f, the coordinate axis, and the vertical line x equals k. All right, so there it is. I can see x-axis, y-axis, this curve, and the vertical line x equals k, where k is greater than 0. The region R is shown in the figure to the right. Okay, right, but does not evaluate an expression involving the integral that gives the perimeter of R in terms of k. Okay, perimeter. So I want to add this up. So I'm going to write P equals P for perimeter. This distance there is 1, so I'm going to write 1 plus, and then this distance here that I'm doing in green, that's k. So I'm going to write plus k, and then plus, and then let's see, this one here in blue, that's just this value, e to the 2k, plus, and now I need to do my integral. So I'm going to use purple. So here's this in purple. That's just arc length, right? Or that's just length of a curve. And this, they don't tell you, this is not parametric, it's not dx dt and dy dt. So we're just going to go plus integral from 0 to k, and this is a function in terms of x. So it's going to be the square root, and instead of dx dt, we're doing dx dx, right? So dx dx is 1 plus parenthesis dy dx, close it, squared, and then I'm going to put a dx over here. All right, they don't want it like that. Wrapping an expression involving an integral that gives the parameter of r in terms of k. So you don't want this dy dx, you want everything in terms of k. So here it is. I'm going to take this equation, I'm going to take a derivative because that's what that dy dx is. So f prime of x equals e to the 2x times 2, and you want it at k. So I'm going to plug in a k in there. F prime of k equals, actually, you know what? No. We're good. K would have found your slope at k. We don't want that. I was about to do a big error. Plug that in there for dy dx. So I'm going to erase the dy dx, and I'm going to plug in to e to the 2x. 2e to the 2x. And there it is. An integral expression in terms of k. You got 0 to k, and then when you take the antiderivative of this, you'll get your k value, and I think that's pretty much full credit. We'll check in a little bit what the answer is. You could rewrite this as 4e to the 4x, but I would leave it alone like that. We'll look at the rubric in a little bit and see what it says. All right, let's go to the next one. The region R is rotated about the x-axis, so I'm rotating about the x-axis to form a solid. Find the volume V of the solid in terms of k. All right, so here we go. When I rotate this, it's going to look like, let's see. Yeah, this is one of my better drawings ever. When I rotate this, I see a disc, and there it is. That's a circle. Area of a circle is pi r squared. The radius is the distance from that x-axis to this curve there. So that's what I'm going to do. So I'm going to go volume equals pi on the outside, integral from 0 to k, open parentheses. The radius is the distance from here to here. So that is, that radius is this expression, the e to the 2x. So e to the 2x, close it, squared, dx. All right, I think we're okay right now. I think. I don't see any issues. So let's see what that is. Pi on the outside, integral 0 to k. E to the 2x raised to the 2, that's going to be e to the 4x dx. Yeah, let's keep going. I don't see any issues again. Pi on the outside, bracket, I'm evaluating the inside. Antiderivative of that is e to the 4x. Now, if I were doing chain rule, I would have been times 4, but I'm not doing derivative, I'm doing integral. So we're going to multiply by the reciprocal of 4, so 1/4 from 0 to k. The 0 does affect it, guys, because e to the 0 is 1, so be careful there. And they did say it in terms of k, so I'm going to do upper minus lower, so pi, bracket, 1/4. You know what? I'm going to factor out the 1/4. So I'm going to write pi over 4, bracket, and I'm just doing e to the 4x, upper limit minus lower limit. E to the 4k minus e to the 0, which is 1. And there it is. I'm kind of tempted to leave it like that, but I'll go ahead and distribute it, guys. Pi over 4 e to the 4k minus pi over 4. So I don't know. I haven't looked. I did look at the rubric for disclosure, but it was a long time ago. Like, I'm literally talking like, I don't remember whenever I did this question. So I can't remember how the rubric has it. Hopefully it's like that. And yeah, that's it. All right, last question here. It says the volume V in part B changes as K changes. Okay. All right, so this is my volume. So this is my volume expression. If dk dt equals 1/3, determine dt when k equals 1/2. Okay, I think I got it. My volume is, I'm going to write it like this. Pi over 4, parenthesis, e to the 4k minus 1. Or I guess this one here, it doesn't, I mean, I guess it doesn't matter. Pi over 4, e to the 4k minus pi over 4. I'm going to take a derivative. So here we go. My dv dt, I'm taking the derivative with respect to time, is equal to, this pi over 4 stays there, e to the 4k. So, all right, pi over 4 e to the 4k times the derivative of 4k with respect to k, no, not respect to k, with respect to t is going to be 4 dk dt, because I'm taking the derivative with respect to t, not with respect to k. So 4 dk dt. So let me make sure everything's correct. I think I got everything right, guys. And the derivative of power 4, this guy, that's just 0, right? So we're good right there. This 4 cancels out with that 4. So if I didn't do anything wrong, dv dt equals pi e to the 4k times dk dt. All right, so let me see. I think I got everything correct. Find the volume V in part B. B changes as k changes. If dk dt equals 1/3, determine the value. Determine dv dt when k is a half. Okay, I got everything I need, guys. We're good. So dv dt. Oh well, I actually know. Oh no, that's what I'm looking for. dv dt equals pi e to the 4 times a half times dk dt, and dk dt is 1/3. All right, so let's see. Pi and then e4, half of 4 is 2 times 1/3. So my dv dt is nothing more than pi over 3 e squared. And let's see how we did. Let's see if we got all these questions correct. So let me come down here and click there, and it was the question number, the next one. I already did that one, this one right here. All right, so let's see. Letter A, perimeter 1 plus k plus e to the 2k, 0 to k, 1 plus, yeah, we got it. So we got all 3 points there. And letter B, yeah, we got it. Yeah, we did it, guys. We did it. Yay. And then letter C, yeah, we got all these points. dv dt, pi to the 4k, dk dt. Hold on. Oh, yeah, we already canceled out the 4 there. They already canceled out the k equals a half. Pi e squared times 1/3. Okay, they didn't simplify, but yeah, we got it, guys. We did it. We did it. All right, so let me come back here and we'll finish off. All right, guys. I hope that this helped. Please, give it a thumbs up if you feel that this really helped you. And yeah, we'll call it a day. We'll call it a day here. All right. See you guys later, guys. Good luck on Monday. Talk to you guys later. Bye.